In this video, we'll get a sneak peek at the projects that we will build in this course. By the end of this video, you will understand the different projects we will be creating using C# for AI programming. In section 4 of the course, we will be creating an AI that solves mazes. We'll be using TorchSharp, which is a wrapper for the Torch library and the .NET equivalent of PyTorch. For this project, we'll be creating the maze, where the maze will be a 2D array. This maze has 3 values, 0, 1, and 2. Anywhere you see a 0 represents part of a wall, the 1s are the floor tiles, and the 2 is the goal. The AI will start at row 11, column 5, which is at the bottom middle. Row 0, column 5 at the top middle is the goal. But keep in mind the AI can only move anywhere there is a 1. The zeros in this multi-dimensional array are the walls, so the AI will need to learn to avoid the walls. We are going to get experience coding the actions and rewards for the model, training the model, and then visualizing the result of it navigating the maze. The next hands-on project we will build will be able to perform OR operations on 3 input values. The neural network that we build will have 3 input neurons and 1 output neuron, and be performing an OR operation on them. For example, if the input is 1, 0, 0, then the neural network should determine the output to be 1, because it is an OR expression, and one of the values is 1. If, on the other hand, all 3 input neurons have a value of 0, then the output node will have a value of 0, because there were no 1s in the expression. Then we are going to build a classification AI using ML.NET. This AI will be able to analyze text data and classify it into positive or negative sentiments. Specifically, our AI will be able to tell whether a movie review is good or bad. We'll be working with a dataset of 50,000 values that we can get for free online from the IMDb popular movie review provider. After that, we will build an AI that can automatically tell whether an image contains a cute puppy or an adorable kitten. Our goal is to train a machine learning model that can accurately classify these images into their respective categories. But wait, how do we do that? Well, we'll start by gathering a dataset of labeled images of puppies and kittens. Then, we'll pre-process the images to ensure they're all the same size and format. After that, we'll use ML.NET to train a machine learning model on this data. In our code, we'll use ML.NET's powerful APIs to load the image data, define our machine learning pipeline, train the model, and evaluate its performance. Next, we will create a regression AI that predicts housing prices based on features such as square footage, number of bedrooms, bathrooms, location, etc. Imagine having the power to predict house prices accurately based on various features like square footage, number of bedrooms, bathrooms, and neighborhood. That's exactly what we'll be able to achieve together with our regression AI. Then we will be creating a forecasting AI that predicts the future prices of stocks. Get ready to dive into the world of ML.NET and C# as we unravel the mysteries of predicting the future. We're combining the power of ML.NET with the versatility of C# to build an AI that can foresee trends and patterns in data, helping you make informed decisions. In this section, we will be creating a program that is able to forecast the future prices of stocks based on data points like the open, close, high, and low values for the stock over a period of time. After that, we'll be building a powerful movie recommendation system that can suggest movies based on user preferences and past viewing history. This is the same technology that powers recommendations on popular platforms like Netflix and Amazon. Our system will leverage collaborative filtering techniques to predict what movies users will love. We'll use the Movie Lens dataset, which contains millions of movie ratings from real users, to train our model. By the end of section 11, you'll have a fully functional recommendation AI that can make accurate and personalized movie suggestions. Next, we will create a sentiment analysis AI that determines if a movie review is positive or negative. In a movie recommendation AI, sentiment analysis can be used to enhance the recommendation system by understanding user preferences better. For example, by analyzing user reviews of movies, the system can identify not just what movies users watch, but how they feel about them. Positive sentiments towards certain genres, directors, or actors can be used to refine recommendations. Sentiment analysis is a powerful tool that helps us understand the emotional tone behind a series of words. We'll be focusing on analyzing movie reviews to determine whether they are positive or negative. Then we will be creating a network traffic anomaly detection AI using ML.NET and C#. In the context of this example project, anomalous network traffic refers to patterns or behaviors in the network data that deviate significantly from what is considered normal or expected. Anomalies in network traffic can indicate potential security threats, operational issues, or unusual activities that require investigation. By the end of Section 13, you'll have built a complete anomaly detection system for network traffic using ML.NET and C#. After that, we will develop a text generation AI that generates Shakespearean-style text based on user input. The way it works is that you enter some input, and then the AI will output some words that continue that idea and are in the style of Shakespeare. This architecture allows our model to understand the context of the input text and predict the most likely next words or phrases. Next, in Section 15, we'll create a time series analysis AI. Our time series analysis AI will be able to predict future website traffic based on prior data on the date, hour, and number of visits. Time series data is a sequence of observations collected at regular intervals over time and finds applications in a wide range of fields including finance, economics, healthcare, climate science, and more. In Section 16, we'll be creating a clustering AI that groups customers into clusters based on their purchase history. In this project, you will use unsupervised learning techniques to group customers based on their purchasing behaviors. This type of analysis can help businesses understand different customer groups and tailor marketing strategies accordingly. We are going to load the data, which will include data points like custom ID, annual income, and spending score. Then we will train the model, and finally we will evaluate and test the model. Then we will create a reinforcement learning AI that learns how to play tic-tac-toe. Reinforcement learning is a type of machine learning, where an agent learns to make decisions by interacting with its environment. Unlike supervised learning, where the model learns from a labeled dataset, reinforcement learning is based on the idea of learning from feedback. The agent takes actions in the environment, receives rewards or penalties based on those actions, and uses this feedback to improve future behavior. The ultimate goal of reinforcement learning is to train an agent to maximize cumulative reward over time, in the case of this project, winning the tic-tac-toe game. Finally, we will be developing an ML agent in the Unity game engine, which will be a Super Mario 3D character. He will learn to collect coins via concepts like rewards and a greedy algorithm. He will also be able to navigate using pathfinding and obstacle avoidance strategies, so that Mario learns to avoid enemies and obstacles in the environment. This will provide us with an understanding of how AI concepts and algorithms can be used to create artificially intelligent game characters.